Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. If a person can select 3 presents from 10 presents under a Christmas tree, how many different combinations are there? Say for example, you are that person and you are allowed to take 3 presents under the Christmas tree with 10 presents. This is surely a problem of combination. Aside from the word combination is already there, it's because no matter which present you're taking first, you're taking second, and you're taking third, it's the same whenever you're going to rearrange all of those. Say for example, you're taking a toy car, you're taking a ball, you're taking a rocket. If you're going to rearrange them, it's the same 3 presents you're taking under a Christmas tree. So again, this is under combination. The formula for combination is in this manner. You have N, C, R, where N will be the number of presents that you can choose from. That's actually 10 presents. And R is the number of presents you are taking at a certain time. So that's a 3. So you can plug in this in your calculator if you would like to. We have 10, C, 3, and you will automatically get a result. But for a process here, let's show the manual steps. The formula for our combination is n factorial over, you will have this expression here, n minus r factorial, then you will have your r factorial. So simply plug in all the values here. 10 factorial for our numerator, and for our denominator, that's actually 10 minus 3 factorial. 3. The result for that will be under factorial, and you'll have here 3 factorial, which takes us to this result. You have 10 factorial over, you will have 7 factorial, that's 10 minus 3 times 3 factorial. You would know that your process is really under combination because you would see that the numerical figures, not the notations, not the factorial notations, but the numerical figure you can find in your denominator, 7 and 3 sums up to 10. Again, only the figure, not 7 factorial and 3 factorial, you add them will result to 10 factorial, just the numerical figure. Now we know that any n factorial is actually the condensed way of writing products of integers 1 to n. In reverse order, you have n times n minus 1 times n minus 2 until you reach 1. That would mean our numerator, 10 factorial, can be written like this. 10 times 9 times 8 until 1. But I will end here until 7 factorial. It's because my denominator already contains 7 factorial. Now, you don't need to do this if you're using calculator, but since I'm doing this manually, I have that. I have 7 factorial here. I also have 7 factorial here. That's why I could cancel them, because both terms that can be found in numerator and denominator are separated by multiplication. Of course, I could always extend this 7 times 6 times 5 times 4 times 3 times 2 times 1, the same with the denominator here, but they will be cancelled out. Now, I would like to have a process where it's easier for me using it manually. So let me express a 3 as its its usual form. You have 3 times 2 times 1. Why I'm doing this? Such that I could also cancel here the 2. I could cancel here 2, so I'm already removing 3 factorial, which is expressed in this form. When I cancel 2, or when I take 2, a factor of 2 from 10, I have here 5, right? Again, I'm doing this manually. Then I could also cancel 3 here from 9, because 9 is a 3 times 3. So instead of a very long, very complicated fraction form, I now have a fraction with denominator 1, which means I could only multiply the numerators. Instead of 10, 9, 8, 7 factorial over this, I only have 5 because 2 from 10 is already cancelled here, times 3 because the 3 from 9 is also cancelled here, times 8. So it's easier for me to look at that result. So I have here 5 times 3 times 8. Manually, 5 times 3 is 15 times 8, I have 120 combinations because that's 15 times 8. So the number of ways that a person can select 3 presents from 10 presents under a Christmas tree, there are 120 combinations because it doesn't matter for this problem to which present will be selected first, second, and third because it's the same 3 presents selected from 10 presents under the Christmas tree. This is the answer for this item, and that's Count It In. Talking about getting the luck of the draw. For all in, subscribe now.